Welcome. In this session, we will master the art of troubleshooting data ingestion in Snowflake, focusing specifically on determining resolutions for ingestion errors. Let's get started. To effectively troubleshoot, we first need to define what we are dealing with. In Snowflake, data ingestion happens primarily through bulk loading using the copy command, continuous loading via Snowpipe, or low-latency row loading with Snowpipe streaming. An ingestion error occurs when this flow is interrupted, flagging files or rows with statuses such as load failed or partially loaded. These aren't just random glitches. They usually stem from specific root causes like a mismatch between your file format and the actual data, invalid security credentials, or access issues with your cloud storage stage. Recognizing which ingestion method is failing is your first step toward a resolution. This diagram visualizes the high-level ingestion landscape. Data moves from your source to a stage, where it branches based on your chosen method. Standard batch loading via copy into continuous Snowpipe or the streaming API. Regardless of the path, the process culminates in an outcome. While we aim for loaded, our focus here is the failure path, which triggers the error analysis phase we are about to explore. Why do we invest time in this? First, data latency. Every error delays the availability of data, stalling downstream analytics. Second is data integrity. If you have partial loads where some rows make it and others don't, your reporting becomes unreliable. Third, consider the cost. Repeatedly retrying failed loads or using inefficient error handling options like skip file on large files wastes compute credits. Finally, leveraging automated error notifications through services like Amazon SNS or Azure Event Grid allows you to react immediately rather than discovering missing data days later. This mind map breaks down the impact of ingestion errors. At the core, we have the error event itself. Branching out, we see the hit to data availability causing latency. We see the threat to integrity via missing rows. We see the financial impact in wasted credits. And crucially, we see the response branch, highlighting the need for error notifications to trigger manual or automated intervention. Now, how do we find these errors? Your primary tool is the copy history table function in the information schema. This gives you near real-time details on load activity for the last 14 days. For longer-term analysis, use the account usage, copy history view, which retains data for a year but has some latency. In both views, look specifically at the first error message, first error line, and status columns. These are your smoking guns. For Snowpipe specifically, the system$pipe status function is invaluable for checking if a pipe is running, stalled, or has pending files queuing up. Here we see the identification sequence. The user initiates a load which returns a failure status. The user then queries the history views. Snowflake returns specific metadata like the error message and line number. The user then uses this specific output to analyze the root cause, bridging the gap between a generic failure and a specific, actionable problem. Sometimes the history view only shows the first error, but you need the full picture. This is where the validate function comes in. It returns all errors encountered during a previous copy execution, allowing you to fix multiple issues at once. For Snowpipe, use validate pipe load to scan a time range for errors. Furthermore, you can proactively prevent errors by running your copy command with the validation mode parameter. Setting this to return errors allows you to simulate the load and catch parsing issues before they corrupt your tables. This diagram classifies our validation toolset. We have the validate function for past jobs, validate pipe load for ongoing pipes, and the validation mode parameter for pre-flight checks. All of these methods feed into a standardized output structure, providing the error message, line number, and column name necessary for remediation. Let's talk resolutions. If you see parsing errors, you likely need to adjust your file format options. Perhaps your delimiters are wrong or quotes aren't handled correctly. For Snowpipe not picking up files, verify your event notifications. Often the issue is a disconnect between the cloud provider's messaging service and your notification integration. If you face string too long errors, decide if you should truncate the data using the truncatecolumns option or resize your target table. Finally, for access errors, verify your storage integration permissions or rotate your access keys if they've expired. This flow logic guides your resolution strategy. Starting with the detected error, we branch based on the type. Parsing errors lead to file format adjustments. Access errors point to storage integrations. Data mismatches require schema or truncation changes. Missing files mean checking event notifications. All paths lead to retrying the load, closing the loop on the resolution. To prevent future headaches, follow these best practices. First, set your on-error parameter carefully. Continue keeps things moving but might hide data quality issues, so use it wisely. Always configure error notifications so you aren't monitoring manually. Regularly audit the load history view to spot recurring patterns. If a specific file type always fails, fix the upstream process. Finally, use the purge equals true option to clean up staged files only after you have confirmed successful loading, keeping your stage clean and performant. This state diagram represents a healthy ingestion lifecycle. We start by configuring the load, explicitly setting the on-error policy and enabling notifications. We then run the load. The cycle doesn't end there, we enter a monitoring state. If the history shows clean loads, we finish. If recurrent errors appear, we transition to optimize format, refining the process for the next cycle.